Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 12, Section 7, Simple Probability. There are three different things we're going to discuss in this video. We're going to talk about sample space, theoretical probability, and experimental probability. All sounds big and scary, but really it's very simple. So sample space is basically all the potential outcomes you have when working with something. So for example, the first sample space I have shown is just the numbers 1 through 6. If you're rolling one 6-sided die, there are 6 possible outcomes, and I have listed those as 1, 2, 3, 4, 5, 6. That is my sample space. If you're down here in this chart, I have a different scenario where we have 2 coins being tossed. Each coin has a potential outcome of heads or tails, and that is represented here in the top and the side column. And the sample space would be what is highlighted in blue, and those are all my potential outcomes. I can get heads heads, heads tails, tails heads, and tails tails. So that's just all sample spaces. We're not going to be doing a whole lot with that. Sometimes creating the sample space can make finding the probability of something much simpler. Can ease the process because it gives you a good visual of the potential outcomes. Sometimes a sample space is kind of unrealistic depending on how big your sample space is. I mean, if you've got thousands of numbers in your sample space, probably not going to be too useful for you to create one because it would take so much time. But let's get down to the probability aspect of things. There are two types of probability. There's theoretical probability, which is what should occur in an experiment. For example, when flipping a coin, getting heads should be a 1 out of 2 chance. There should be a 1 in 2 chance of getting heads when you flip a coin because there are 2 possible outcomes and one of them is heads. So when you're talking about a coin, when you're talking about theoretical probability, basically it is the number of favorable outcomes over the number of possible outcomes. So when flipping a coin, the possible outcomes are 2, heads or tails. The number of favorable outcomes, if you're looking for heads, is just 1. There's only one side that has heads on it. So there's only one favorable outcome, but there are 2 possible outcomes because I could also get tails. So there would be a 1 in 2 chance of getting heads. There would be a 1 in 2 chance of getting tails. If you're rolling a die, there's a 1 in 6 chance that you will roll a 1 because a die has 6 sides with 6 different numbers on them. One of those numbers is the number 1, so that is your one favorable outcome. The number of total possible outcomes is 6 because there are 6 different sides to the die, so there's 6 different outcomes for your roll that are possible. Rolling an even number on a die, there is a 3 in 6 chance, which can be reduced to a 1 in 2 chance. They're the same thing. There's a 3 in 6 chance because there are 3 even numbers on a die, 2, 4, and 6. So the total number of favorable outcomes that you're looking for are 2, 4, and 6. So there's 3 possible favorable outcomes, and there's a total of 6 possible outcomes when you include 1, 3, and 5 as well. So there's a total of 6 sides to the die, and only 3 of them are even. So it is a 3 out of 6 chance. That is the theoretical probability. The assumption with theoretical probability is given the number of sides and given the number of favorable outcomes, theoretically, you should roll an even number roughly every other turn, so every 1 out of 2 chances. The experimental probability is what actually happened. As most of us know, theoretical probability isn't always 100% accurate. You can roll a die 100 times, and it doesn't. The theoretical probability doesn't guarantee that you're going to get an even number 50% of the time or every 3 out of 6 chances. It doesn't guarantee that every 1 in 2 rolls is going to get you an even number. It's saying that's theoretically what should happen when given to the law of averages and what have you. So what you do with experimental probability is you take a look at the data that you received from the experiments. So if we were flipping a coin, once again, we talked about how when you flip a coin, there's a 1 out of 2 chance that you can get heads, and there's a 1 out of 2 chance you can get tails. So you may flip a coin 25 times, get heads 14 times, and get tails 11 times. And so then the actual experimental probability ended up being that you got that you rolled heads 14 out of 25 times and you rolled tails 11 out of 25 times. So it wasn't quite 50-50. It wasn't exactly a 1 out of 2 probability as a theoretical probability would have stated. Theoretically, you should have flipped heads 1 out of 2 chances. But instead, we hit heads a little bit more than 1 out of 2 chances. We hit heads a little bit more than 50% of the time. And we hit tails a little bit less, even though tails was supposed to be a 50% chance as well. So really kind of the difference between theoretical is theoretically with the coins, there is a 50% or a 1 out of 2 chance you'll get heads, and there's a 50% chance that you'll get tails, but it doesn't guarantee that you will get it because really every time, kind of what theoretical probability is saying, kind of the difference here between experimental and theoretical is every single time you flip that coin, there's a 50% chance. It's not saying that your second time is guaranteed because the second time that you flip that coin, again, there's a 50% chance that it'll land on heads. So each time you flip that coin, there's a 50% chance. So the theoretical probability can kind of guarantee you that, yeah, you do have a 50% chance of getting heads on this flip, but it does not guarantee anything about the second flip, other than the second flip is also a 50% chance. But it's not going to say that the second flip is definitely going to be a heads if you didn't get tails the first time, because each flip has a 50% chance. So each flip has a chance of not getting heads as well. Whereas experimental probability is what actually happened when you did it. Now, experimental probability, however, again, is it's all related to the experiment you conducted. It's not guaranteeing anything for anyone else. I could have done this experiment and flipped a coin 25 times and gotten these results, and you could do the same experiment and get heads every single time because every time you flip that coin, there's a chance you could land on heads, and it is possible for that coin to land on heads every time. So experimental probability, this is how you do it. You put the frequency it occurred over the number of experiments you tried. So it occurred 14 times. I tried it 25. It occurred 11 times. I tried it 25 times. And again, experimental probability only relates to your experiment. It does not guarantee anything about anyone else's experiment. But this is how you get the probability. And as with anything basically related to fractions and ratios and what have you, you can convert these fractions into ratios, into percentages. So a 1 out of 2 probability of 1 out of 2 is the same thing as saying you have a 50% chance, because 1/2 represents 50%. So just keep that in mind as you go forward with this section, but that really is all there is to the section. That's what you're going to be doing in this section. If you have any questions, make sure you pause the video, raise your hand, let me know, and make sure you're taking good notes. Rewind the video if you need to take notes. And again, ask questions when you get confused. Next video will be on Chapter 12, Section 8.